All right, good morning and welcome to Master Talker online class. In this series of solving fundamental quantities question, right? We are in chapter 2. In our previous video, we did chapter 1 where we talked about unit and dimensional analysis. So if you have not watched that video, I will drop the link on the description. You can watch that. So we are in chapter 2 where we want to talk about vectors. And don't forget that in this series, we are just solving strictly calculations on this topic. We don't want to treat about uh, what you mean about vectors and the rest. You have a full video on vectors. You can watch that. So we're here for calculations. So if today is your first day of watching our video, we'll bring you videos on physics, maths, and chemistry, strictly calculations, okay, of WAEC, JAMB, NECO, and university questions. So if you are new, just click that subscribe button so that anytime we drop a video, YouTube will notify you. Then if you have any question on these subjects, maths, physics, and chemistry, you can bring it to us. We'll help you tackle it. So in this video now, they said a river 50 cm wide. So let's say that this is the width of that river. This river is 50 cm wide. Okay. Now we now have that. They now say that a river 50 meter, 50 meter wide is flowing due east. Okay, this river is flowing like this, due east. Okay, don't forget that this is your cardinal point and this is your east, north, south, and west. So it's flowing like this from west to east. It's flowing due east at a velocity of 30 meter per second. So it's flowing with a velocity of 30 meter per second. So the velocity this thing is moving is using to float is 30 meter per second. I can say that okay, let's just leave it. It's flowing. Then they say that a man wishes to roll his boat due north. This man wants to move due north. So let me say that this is point A. Okay, the man wishes to move like this. The man wishes to move from point A to point B. He's moving due north. All right. Don't forget that this river is moving like this, and the man wants to cross to the other side of the river. And they say that this man is moving with a velocity of due north across the river. If he can roll the boat in still water at a velocity of this, he's moving with this velocity. And you should know that if somebody wants to cross from this side to this side of a river and the river is moving this way, that person should move opposite the river so that the friction will help him to move. But if he's moving in the direction of the river, there won't be friction, so the river might carry him to another place. Okay, the river will just flow with him, so he has to move in this direction. So if the man moves with this direction, this is the direction the man is moving. Okay, and don't forget that this man is moving with 50 meter per second, and this river is flowing this way. This river was flowing with 30 meter per second. All right, so then I say calculate the direction he must head. So this is the direction he must head. Let's find out the angle this man is going to move. All right, so we have opposite over hypotenuse, so I'm going to use sine. So this is sine theta is equal to opposite, which is 30, divided by what? Hypotenuse, which is what? 50. So therefore the theta will be what? The sine inverse of 30 divided by 50. So I'm going to have sine inverse of that to give you 36.86 degrees. Okay, approximately 37 degrees. Okay, so this man must move 37 degrees west of the north. Okay, he's going to move. This is west, don't forget, this is north, and this side is east. So he's going to move this man is going to move north 37 degree west before he can get to the other side of the river. Very, very simple to calculate. So go to the next question. The second question here said the time it will take this man to reach to the other side of the river. Now, to calculate the time it will take this man to reach to the other side of the river, first of all, we need to calculate the distance from here to here. Okay, we need to get the distance from here to here. But first of all, let us get the displacement from here to here and see what we are going to have. Now we have that. Let me call this place x. We want to get the speed here. So using Pythagoras theorem, we'll see that what? 50 squared is equal to what? X squared plus 30 squared. All right. So I'm going to have that my x squared is going to be 50 squared minus 30 squared. So I'm going to have that x squared is equal to, if you do that, you're going to have 1600. So x will now be the square root of 1600, which will give you what? 40 meter per second. So this is the speed. Okay, this is the speed that this man need to use to cross if you want to move straight, because he wants to move from here to here. This is the actual speed that that is required of him. Now the next thing we need to, they say we should calculate what the time it will take. Okay, now for the time it will take, we should know that this river, the river is 50 cm wide. This river is 50 cm wide. So from here, now let me tell you the reason we calculated the speed from here to here is because this river from here to here is 50. This is 50-meter wide. Okay, so we need to calculate the same velocity, the same vertical velocity. So we need that what velocity is equal to what, or let me say distance, speed, or let me use speed. Speed is equal to what, distance over what, over time. So now therefore we now have that what, my time will now be what, distance over what, the speed. So and the distance is what, 50 divided by the speed, 40. So 50 divided by 40 will give you 1.25 seconds. 1.25 sec. So 1.25 sec. So that is the time it will take the man to get to that point. All right, it's very, very simple. We move to the second question. So the second question here said, question number 2 for vector said three forces of magnitude 10 Newton, 4 Newton and 3 Newton, okay, act on a body in the direction north, south and east, okay, respectively, full stop. Then I say find the magnitude and direction of the resultant force. Okay, solution. Now to find the magnitude and resultant of this direction, resultant force, first of all we need to draw it. I have my cardinal points. These are my cardinal points. So the first one is moving due north, and the one that is moving due north is 10. So I have that here is what is 10 Newton. The other one is east, and the east I have which one is east? 3 is for east, so I have that 3 Newton. Then finally for south, I have that south is what, is 4 Newton, right? So to get the resultant of this force, we are going to resolve it both horizontally and vertically. Okay, so in fact the easiest way is that this one is negative, this one is positive, so this will minus this. This is down, negative, this is up, positive. So for the vertical, I'm going to have 10 minus 4, which is what, 6 Newton. But for the horizontal, I'm just having only 3, so I have 3 Newton. So the direction, the resultant force is always acting towards the middle. So if I cut here, I'm going to see that here is 6 Newton. So this is their direction. So using Pythagoras theorem for the resultant, I have that r squared is equal to 6 squared plus 3 squared. So my r squared is equal to 36 plus 9. So my r squared is equal to 45. So my r will now be the square root of 45. And square root of 45 will give you 6.71 Newton. Very, very simple. I don't want to start resolving it using resultant of vectors. Okay, you can watch my video on that to understand that. Okay, so the next one is the direction. The direction I'm having opposite over adjacent, so I'm using tan. So tan theta is equal to opposite 6 over adjacent 3. So therefore my theta will now be what, the tan inverse of 6 divided by 6 over 3, and which is what, the tan inverse of 2. And tan inverse of 2 will give you 63.4 degrees. 63.4 degrees. All right, so 63.4 degrees. So which is something as what, if here is 63.4 degrees, now I have that here is my north and here is my east. Now you can write it this way. Listen, you can write it that this is this angle is with the horizontal. So it's either you write that this is what, east 63.4 degree, 63.4 degree north, or you can get this place. To get this place is by just by saying 90 minus this. So if you press 90 minus 63.4, you're going to get that here is 26.6 degrees. So you can call it, if you are using this side, you now call it north 26.6 degree east. So any of the two is the correct answer for that. All right. So that is approximately 27 if you want to approximate. So that is that. So we'll go to the next question. Question number 3. So question number 3 said, now question number 3 said a helicopter has an airspeed of 100 kilometer per hour and flies on a course bearing 150 degrees, that is east, 60 degrees south, right? Then I say a wind is blowing steadily at 30 kilometer per hour from a bearing of 080 degrees. Then I say that is north 80 degrees east. Okay, north 80 degree east, full stop. Then I say find the track and the speed, okay, and ground speed. Then I say note that wind vector plus cos vector is equal to the track vector. Okay, so wind speed and so therefore the wind speed plus the cos speed is the track speed. Okay, solution. Now let us draw that. Now drawing this, we have that now we have that they say that what a helicopter has an airspeed of 100 kilometer and flies on a course bearing of, let me draw the bearing here, and flies on a course bearing of 150 degrees. Now if I have my cardinal points like this, this is the second quadrant, so 150 comes here, so I will draw my 150. So from here to this point is my 150. So if here is 150, to get this small place we can say 180 minus 150. So we have that here is 30. So that is why they say that it is equally east 60 degrees south. So east of south is this place. So if I don't want to use that 150, I can use the other one they told me. I don't want to use the 150, so let me use the other one they told me. So the one they told me is that here is my south, here is my east, my south, my north, and my west. So it is, they say that is what, south 60 degree, east 60 degrees south. So east 60 degrees then south. Okay, and they gave me that the distance, that the speed it uses is what, 100 kilometer per hour. So they told us that the next one moves with a speed of the other one was moving 80 degrees north, 80 degree east. Let me come down so that it can enter. Let me come down to this side. Okay, so I have the first one like this, and it is 60 degrees. 60 is bigger, so let me make it bigger. So let me say that 60 is somewhere here. So here is what? 60. This is my east and south, and it's very long. So this is my 100 km. Okay, so the next one they told us is 6 what? North 80 degree east. So it should be, this is north and east. So from here to here is that 80 degrees. So to get this small place here will now be 20 degrees. So from here to here is what? 80 degrees again. Okay, so now they can now meet. You can now join them. You can now join them. But before joining them, let me show you how to get the bearing that side. So to this side is what's the distance? The distance here is 80, while the other one is 100. So 80 should be smaller than 100. So I have something like this. I cut like this, then come to this point, cut like this, so that they can join. In fact, let me make this one a little bit longer. Then I can make this one a little bit shorter. Then like this, so they can join from here to here, right? So now what did they say we should calculate? They say we should calculate the okay. So now for us to get the resultant is from here to here. This is the resultant. What they say we should calculate? Find the track. Okay, first of all let me get the resultant r. To get the resultant r is equal to, here is 80, right? Sorry, the wind is blowing with 30. 30 is too small. So this thing is, I should make it a little bit shorter again. The one confusing myself. So this is 30. Here is 30 kilometer per hour. So this one is 100. 100 should be very long. Kilometer per hour. So I cut like this. Then this one, let me cut it here, so that it will join from here to here. Aha. This is perfect. Okay. Let me write this here. 30 kilometer per hour. Now, this is their resultant. To get their resultant r, I'll have that r squared according to cosine rule. So I have that r squared is equal to what? 30 squared plus 100 squared minus 2 times the same 30 times the same 100, then cos that angle facing it, cos 80. You can watch my video on bearing and distance. I'll drop the link on the description. Watch my video on bearing and distance. It will help you to get this. So if you press everything there once, you'll be having let me press it. 30 squared plus 100 squared minus 2 in bracket of 30 in bracket of 100, then cos 80. So everything is giving me 9858. Let me see if the same thing as what I got. Okay, so everything is giving me 9858.11. Okay, so then the square root of my answer. So my r will now be the square root of 9858.11, which will give you 99.288 kilometer per hour. All right. So now, so that is that for that. It's very, very simple to get. So the next thing they say we should calculate is what? So what else did they say we should calculate? So I've gotten the resultant, which is 99 degrees. So the next thing, what else they say we should calculate? Find the track and the ground speed. This is the ground speed. This is the ground speed. Okay. Then for the track, we need to get the angle here. Let us get the angle here. Theta. Okay. Let us get the angle here, theta. And then what else do we do? Okay, to get this angle, we say that sine theta all over the one facing it 30 is equal to what? Sine 80 all over the one facing it r. So if I do cross multiply, I'm going to have that what is my r? My r is going to be 99.288. Okay. So what do I have now? You cross multiply, you're going to have that sine theta is equal to 30 sine 80. divided by 99.288. So therefore, sine theta will now be, let me press it once. So I have 30 sine 80 now divided by 99.288. So I have 0.29756. So theta will now be the sine inverse of that 0.29756. So if you do the sine inverse of that, your answer, you have 17.31 degrees. Okay, so we have gotten that side as 17.31 degrees. So now the next one now, the answer that the track vector is simply the cos vector plus, like they gave us here, is the cos vector plus the wind vector. What is the cos vector? And then what is the wind vector? The cos vector, okay, the cos bearing is 150, and we have gotten that the wind bearing is this one. So therefore, my track vector, the track vector is equal to what? They gave us wind vector plus our cos vector. Okay, so which is our wind vector, it was blowing with the cos vector is 150. So we have gotten the wind vector as 17.31 plus 150, which is what? 167.31 degrees. Okay, so that is that. We move to the next question. Question number 4. Please watch my video on bearing for you to understand it very well. Okay, after watching my video on bearing to understand how to draw bearing, then you now watch my video on cosine rule, sine and cosine rule. It will equally help you to learn how to calculate it after learning how to draw the bearing. All right, so the next one said a man, question number 4 said a man set out to swim across a river 0.4 kilometer wide, okay, at right angle to its parallel bank. Then I say he can swim at a steady speed of 2 kilometers per hour in still water, but there is a current flowing at 1 kilometer per hour. Then the next say find his track across the river. Then B, they now say how far downstream he is carried when he lands. Okay. So this is almost the same question with the other one. So we have the river like this. Now, if we have the river this way, they say that this man wishes to cross directly. Okay, he wishes to cross from here to here, and this river has the distance. They say a man set to swim across a river. This river, the distance from here to here for this river is 0.4 kilometer. Okay, and this man wishes to cross directly parallel this way. And then this man was moving. In fact, normally the river was moving with 1 kilometer, 1 kilometer per hour. And that man wishes to cross this way. Let me say the man is going to is moving this way, directly parallel at an angle of 90 degrees. the man was using an angle of 90 degrees, and the man was using a speed of 2 kilometers per hour. That is the speed this man is using. Okay, but but the problem here is that we need to find something. They said, but there is a current that is moving. Okay, the current is, this is the current moving this way. Then they say find a track across the sea. Now, if this man is moving this way, he's moving like this, so but the water is going to be carrying him like this. So let's see the angle this water will carry him to. He's moving straight. He was not moving opposite. He was moving straight. But definitely, as he's moving like this water will be moving him this way. Okay, so this is the angle. Where do we put the angle? Okay, let me say that this is the angle that is formed, for instance. All right. So now, what do we do to find the resultant? To find this resultant, we will have that the resultant will now be r squared is equal to Pythagoras 2 squared plus 1 squared. So r will now be the square root of what? 4 plus 1. So r is equal to the square root of 5. And square root of 5 will give you 2.236 kilometer per hour. All right. That is the first question. His track across the river. This is his track across the river. Now the next question say how far downstairs he is. He is carried when he lands. Okay, when he's going to land, oh, this is the angle we are looking for. When he's going to land to this side, what angle was made? That's what they're asking us. When he's going to land to this side, what angle was made? So if you look at this, is opposite of adjacent. So I'm using tan. So tan theta is equal to opposite, which is 2, over what? Adjacent, which is 1. So I have that theta will now be what? The tan inverse of 2. So tan inverse of 2 will give you 60 what? 63.43 degrees. So that is the angle that was made when he landed. So the next question, question number 5. Out of how many questions? Okay. So question number 5 said okay, they say how far means the displacement, not angle. So this is the angle he's going to make when he gets there. So how far he's going to take to that point is how far is it? You can try calculating that anyways. I'm trying to get confused. They say how far downstream he is carried when he lands. Okay, how far downstream he is carried when he lands. Okay, now, okay, oh, that is, we want to find the distance. Let's find the distance. Don't forget we have that drawing. In that drawing we have something like this. We have a triangle that is like this. Okay, and in the triangle here is 1 kilometer, and here is a 2 kilometer per hour. Here is 2 kilometer per hour. Okay, and then we have that the distance of this thing is 0.2. Okay, the wide is 0.2, the width is 0.2. Where is it? The river is okay, 0.4. Okay, let me change this place to the distance 0.4 kilometer. Okay, we need to know the distance this man moved from where he is, the distance he moved when he, okay, we need to find this distance using this distance, but we know an angle here. An angle here gave us 63.43. So we now say opposite over hypotenuse. So we have that sine 63.43 is equal to the opposite 0.4 over what? Hypotenuse x. So x will now be what? 0.4 divided by sine 63.43. What do you have? Sine 63.43. Then we now have 0.4 divided by my answer. So it's giving me 0.44. So 0.44. or 45 rather, 0.45 kilometer. So this is the distance that man moved, how far he went. Okay, so this is how far he went. So let's move to question number 6. So, or question number 5 rather. Question number 5 said a ship is traveling at 10 kilometer per hour. Okay, then I say a ball is rolled across the deck. Then I say at right angle to the motion of the ship. Then I say at a speed of I cannot really see that speed. Okay, at a speed of 4 kilometer per hour. At a speed of 4 meter per second. 4 meter per second. Then I say find the actual velocity of the ball relative to the ground. Okay, now first of all, this thing is in meter per second. They're supposed to be the same, so it's a typographical error. This is equally meter per second. Okay, so I have this. I have that this is the river and this boat wishes to cross. Okay, as the boat is crossing, they say that a ball is rolled at right angle. So this ball rolled this way at right angle, and then the ball was moving with 4 meter per second. Okay, then I say a ship is moving. The ship is moving like this. Okay, so that ship is moving this way. So then I say find the actual velocity. If the ship is moving like this and the ball is rolled this way, so the movement should be opposite the actual velocity of the ball. The actual velocity, if you want to get the actual velocity of the ball, then that ball is supposed to be moving opposite the way the river was moving, or in opposite direction to the other one. So it's going to move like this. So this is the actual velocity. So here is x, but the ship was moving like this. The ship was moving with 10 meter per second. So if you use Pythagoras theorem, you are going to get, and then this is the angle to get the direction, the actual velocity. So we can get the direction if we want. So therefore, what do we have there? So we have that x squared is equal to 10 squared plus 4 squared. So we now have that x squared is equal to 100 plus 16. So x squared will now be 116. X will now be the square root of 116. So x is equal to square root of 116 will give you 10.77 meter per second. So you can decide to get the direction. The direction is what? This is opposite over adjacent. So you have that what? Tan theta is equal to opposite 10 over adjacent 4. So theta will now be the tan inverse of what? 10 over 4, which is what? Tan inverse of 10 over 4 will give you 21.8 degrees. All right? So that is that. We move to the question number 6. So question number 6 said a river flows at 3 kilometer per hour and its parallel bank are 400 meter 400 meter apart. Okay, then I say that a man wishes to cross in a motorboat which can make 5 km/h in still water to reach the point directly opposite. Then I say find the direction in which he must steer and the time taken to cross the river. Okay, the same approach, the same thing. So what do we do? Let us draw it again. The same thing again. I have this is the river now, and this river is 400 meters apart. So this is 400 meters apart. All right, then now the river flows with 3 km/h. If the river is moving this way, so this man need to move like this. Okay, let me have that. This man, they said that the man was moving with what? Where is the man? The man was moving with 5 km/h. Okay, so now we know that watch. If this man is moving with, the man need to move like this. If the river is moving like this, so the man need to move this way. And the man was moving with what? 5 km/h. So, but the river was moving with 3 km/h. So we need to find this displacement from here to here, so that to help us get the time. So from here to here will now be x. So then this is the angle the man must make as he's moving. Okay, so to find this place, first of all, so the first thing they say we should calculate is the angle. So for us to get the angle, we can say that this is opposite over hypotenuse. So sine theta is equal to opposite 3 over hypotenuse 5. So theta is equal to what? The sine inverse of 3 over 5. So what do we have? Sine inverse of 3 over 5. Find the direction in which he must steer and time taken to cross. Okay. Okay. So what do we have now? Let's find this x first. I need to get something. I have that x squared is equal to what? 5 squared minus 3 squared. So x squared is equal to 25 minus 9. X squared is equal to 16. X is equal to what? Square root of 16, which is what? 4 km/h. So here we're having 4 km/h. All right. So now to get the angle, the direction is here. So which is what? The sine inverse of this. Yes, that's correct. Shift sine inverse of 3. Okay, so 3 divided by 5. Then sine inverse of my answer. I have 36.89 degrees. So that is the correct answer. 36.89 degrees is the correct result. All right. So that is the direction the man must follow. Okay, the angle he's going to steer to get to that point. So that is that. So we'll go to the last question. Question number 7 is the last question here. They said a pendulum of weight 100 Newton is pulled to an angle of 30 degrees from the vertical Then I say calculate the horizontal force pulling the pendulum. Okay. Then I gave us oh, okay, solution. So this is very, very simple. Let me check my time. 40. Wow. So this is very, very simple. We have that this is question number 7. So we have this. Let me have that this is the ceiling, and they say that the weight, this is the weight of this pendulum, and the weight is what? 100 Newton. Okay. And the weight is 100 Newton, and it is pulled at an angle. We now pull it at an angle of 30 degrees to the vertical. So this is 30 degrees to the vertical. All right. Then I say we should calculate the horizontal force. This horizontal force is the same thing as coming to this side. This is the force we have to calculate. So if you trace it to this side, you have here. So we're having that here is x. This is where we want to calculate. This is opposite over adjacent. So I have tan. So I'm going to use tan. So I will say that what? That tan 30 is equal to what? Opposite x over what? Adjacent 100. So my x will now be what? 100 tan 30. So which is what? 130 will give you 57.73 Newton. Very, very simple. We move to the next question. There is no time. The next question here already gave us something to do. They gave us the ceiling. They said that this is the ceiling, right? And then this is question number 8. And then they gave us something like this, something like this, something like this, and then the weight like this. This is W. And they say that here is theta, and they say that here is 8 Newton, and they say that here is 5 Newton. Okay. To calculate our theta and our W is very, very simple. So here and here is same thing. Here is my W. So cut this place to this side. I have that here is my 5 Newton. So to calculate here, use Pythagoras. So my W square will now be what? 8 squared minus 5 squared. So my W square will now be what? 8 squared, that is 64 minus 25. So my W square will now be 64 minus 25. So I have 39. So my W will now be the square root of 39. So square root of my answer. So square root of 39 is giving me 6.245 Newton. Okay. So that is that. So the next thing to calculate is the angle, the theta. So to get the theta is very, very simple. This is opposite over hypotenuse. So I can use sine. So sine theta is equal to opposite 5 over hypotenuse 8. So my theta will now be what? The sine inverse of 5 over 8, which is what? Shift sine 5 over 8. So 5 divided by 8, then shift sine of my answer. So I have 38.68 degrees. So that is that. So we move to the next question. The next question, that is question number 8. I didn't even write the question, but we have calculated everything they say we should calculate. So we move to question number 9. So question number 9 said they said question number 9 said an object is in equilibrium under the action of three forces, comma, then I say two of which are 50 Newton and 70 Newton and are at angle 45 degrees to each other. Then I say calculate the magnitude of the third force necessary to maintain the object at rest. Now, this is very, very simple. Now, the only object that will maintain this at rest is what we call the resultant force. Okay, the resultant force is the only angle that will keep it at rest. So what do we do? This is very, very simple. We are going to use so it's acting as 45 degrees. So we're going to use what we call you know that the resultant force is going to act for this thing to be at equilibrium. If we say, I want to say something. If we say that the resultant force is what is going to keep it at equilibrium, then we are going to have use our normal formula that say that F1 is equal to my 50 Newton. Let me see. F2 is equal to my what? 70 Newton. Then my theta is equal to what? 45 degrees. And I have a formula say that the resultant square is equal to what? F1 squared plus what? F2 squared minus 2 times the same F1 times same F2, then cos 180 minus that theta. Okay? So I'm having what? 50 squared plus 70 squared minus 2 times 50 times 70, then cos 180 minus 45. So I'm going to have let's do that. 50 squared plus 70 squared minus 2 bracket 50 bracket 70, then cos 180 minus 45. I'm having 12,000 12,349. So my R will now be the square root of 12,349. So the square root of my answer is giving me 111.13 degrees. Okay. So, but what are they having here from the question? Question number what? Question number 9. Question number 9. Okay. So that is the result. So we move to the next question, question number 10. Before the question number 10, they said they gave us something here. Look at another question they gave us before question number 10. Okay. That is 9b. Let me call it 9b. So I have something like this. This one goes this way, and then this one comes this way with a force like this. That force is 100 kg. Okay, they say that here is 60, while here is 30 degrees. So they now say that a crane has they say jib AB. They say that here is C, here is B, where is our A? Let's assume that here is A. Okay, yeah, that place is A. Then they now say hinged at A, inclined at 60 degrees. They say calculate the tension along BC. Calculate the tension along BC. I don't want to start writing the whole story. Okay, let me write it for writing's sake. Inclined at 60 degrees to the horizontal. Okay, to the horizontal, comma, held by a tie BC inclined inclined at 30 degrees inclined at 30 degrees to the horizontal. Okay, then I say that a load of 100 kg a load of 100 kg hangs from B. Then I say neglecting the weight of the jib, neglecting of the jib. Okay, then I say calculate the tension along BC. Okay, so this is very, very simple. Let's make it a complete triangle. I have a triangle like this. The first one goes this way and the second one goes this way. And then here is 30 degrees. Here is what? 60 degrees. And here is 90 degrees. Here is 1000 Newton. I want to use Newton. 100 kg is something as 1000 Newton. And they say we should find, this is my B, this is my A, this is my C. Let me call this place D. Now we have two triangles here. The first triangle is triangle. To find here is very, very simple. If find the tension along BC. Okay. So to find there is very, very simple. So what do we do? What do we do to find here? This is opposite over hypotenuse. If I say sine 30 is equal to opposite 1000 divided by hypotenuse BC. We now have that BC will now be what? Divided by sine 30, which is what? 1000 divided by sine 30. That is 2000. So 2000 Newton. So that is the tension there. It's very, very simple to calculate. I was thinking they will ask us the tension in CA. If they ask us tension in CA, then it will not be a difficult thing to calculate. So that is that. So we'll move to the last question for this particular video and this particular chapter. And this last question gave us something like this. They gave us something like this. They said that here is 100 Newton and here is 150 Newton. 150 Newton. And they say that there is a force here that is 60 Newton. 60 Newton and an angle of 30 degrees. Right? Now, to determine the resultant of these vectors. To determine the resultant of these vectors. So let us analyze it via resultant of vectors. So this is a horizontal, this is x-axis, and this is y-axis. Now, to resolve this one in the y-axis is negative, so it's going to be minus 100. Then for the other side is 0. To resolve this one on the x-axis is at the right-hand side, so it's going to be 150. But for this side, it's going to be what? 0. Now, to resolve this one vertically means this is moving like this, away from the angle. And if you are moving away from the angle, don't forget all St. Teresa's College, away from the angle, use sine. So resolving it vertically is moving away. So I'm going to have that this is a 60 sine 30. But moving it this way is going towards the angle, and towards the angle use what? Cos. So it's going to be what? 60 cos 30. So let's get the total. We are done with everything. So 60 sine 30 will give you 30. So this is equal to 30. So if you do everything here, you are going to have minus 100. So I'm going to have 100 minus 30. So I'm having minus 70 for this side. Okay? But for this side, I'm going to have 60 cos 30. I'm going to have 51 point blah blah blah. So 150 minus, sorry, 150 plus my answer. 150 plus my answer I'm going to have 201.96. Okay, so that is that. So therefore my resultant is going to be this, my r, you are now resolving it like this. Sorry, it's going to be the other side, negative. So this is going to be like this. This is going to be positive x, that is 201.96, then negative y, which is what? 70. So the resultant passes through their middle. If I cut this like this, I'm going to have that here is 201.96. So my resultant r. So my r squared is equal to 70 squared, 70 squared plus 201.96 squared. So I'm going to have plus 70 squared. So I'm going to have 45688.46. So my square root of my answer will now give you, so r will now be, r squared is this, so r will now be the square root of this 45688.46, which is going to give me 213.75 degrees. Sorry, in what? In Newton. So that is that for that. So thank you very much for watching. Please don't forget to like. The more you like this video, the more YouTube recommend it for more people to watch. Bye bye. Thank you.